Hi, I'm Dr. Lisa Welp, and I'm a professor here at Purdue University in the Department of Earth, Atmospheric, and Planetary Sciences. And my field of research is biogeochemistry. So in my field of research, it's very interdisciplinary, but we look at how the biosphere and the atmosphere and the geosphere all interact together. So I have degrees and training in chemistry and geology and environmental science and engineering. There are a number of important global issues that we as biogeochemists study. These include climate change and acid rain, and nutrient runoff that leads to eutrophication of aquatic systems. So we really try to understand the systems and how they work together, what it is that's causing these global problems, and then how we might better find solutions to reduce these issues. One area of research that I've studied is the global carbon cycle. So we're really interested in how the terrestrial biosphere, all the plants on the planet, how they do photosynthesis and remove CO2 from the atmosphere. So in the context of climate change, as we're worried about more and more CO2 being emitted to the atmosphere, the terrestrial biosphere is doing us a huge favor by taking up some of that extra CO2 that we put there. So we want to understand how those ecosystems do that and how they might continue to provide this important carbon sink for us in the future. Another field of research that I've been active in is in the hydrologic cycle. So in this, we study how water moves around the planet. So some areas that I've studied are how plants transpire water to the atmosphere. What happens to that water when it's in the atmosphere? What are the processes by which it forms clouds and produces precipitation? So we can use some chemistry tools, these are called stable isotopes, as little tags to trace these water molecules as they move around in the atmosphere, and as well as whenever they come out of the atmosphere in the form of precipitation and move around the landscape. We can use these little chemical tracers to better understand the processes by which water moves around. So I use my training in the geosciences to better understand how our planet Earth works. The types of things that I do on a day-to-day basis as a research scientist, some of that involves field work, which means going to new places to collect new data. Sometimes it involves collecting samples from the environment and then bringing them back into the laboratory, and then using really sophisticated pieces of instrumentation to study those samples in more detail. And then another part of what I do is a little bit of computer coding. So in order to interpret the data that we collect, sometimes that involves creating mathematical models, right? If we can understand the process and we can express that process in forms of mathematical equations and then test those in the real world, then we can test our understanding of the system, right? And we learn so much from that, from taking our observations, creating models, both conceptual and mathematical models, and then testing those models in the real world. That's really how we know that we understand what's going on in the Earth system. As a university professor, in addition to doing basic scientific research, I also teach. I teach undergraduate and graduate level classes in biogeochemistry, as well as in climate change and stable isotopes. So I think I was drawn to this field in part because I love the outdoors. I love the natural world. And I also recognized that I am kind of a true scientist. I really approach problems by using the process of hypothesis testing kind of in my day-to-day life. So bringing these two things together, my interest in the natural environment and my approach to the world, my scientific approach to the world, to bring those two things together to do research in the geosciences is very rewarding for me.